Here we're given the graph of the function f of x equals the absolute value of x. We are to draw the graph of the function g where it's defined to be 1/2 f of x. And then we are to write the formula for g in the answer box at the bottom of the problem. So we are told that the function g of x is equal to or can be found by taking the function f of x and simply multiplying by 1/2. Remember, in function notation, the x is the input variable, and looking at the original function f and the new function g, notice the input variable has not changed. This means to go from any point on f, when we look to transform a point from f to g, we are to leave the x value alone. What we are to change, however, is the output. Remember that this notation represents the output of g, and this notation represents the output of f. So the statement says if you want to find the output of the new point on g, simply take the output of f, which is this right here, and multiply by 1/2. So your new output will be 1/2, whatever the output of f was, which we're calling the letter y. So to transform the graph of f, you could think of transform the graph of f as transforming many, many points. In fact, all a graph is a collection of infinitely many points. So we can pick any point on f and find the point on the transform function g by leaving the x value alone and multiplying the y coordinate by 1/2. It turns out with the graphing tool on the computer, one of the points that you must pick is the bottom of the absolute value function, the lowest point, which is 0, 0. So I will include that in our explanation, but it makes sense to include a few more points. So for example, let's pick the point 6, 6. And -6, 6, and we will find the transformed point on g for each of these three by simply following the rule that I'm to leave the x value alone. This x value is 0, I leave it 0, and the new output will be 1/2 the old output. So the old output was 0, the output on f. I multiply by 1/2, 0 multiplied by 1/2 is 0. Repeating that process, leaving the x coordinate alone, I write 6, multiplying the y coordinate by 1/2, 6 times 1/2 is 3, and then finally leaving the x coordinate of this point alone, -6, cutting the y coordinate in half, 1/2 of 6 is 3. I can now plot the new points. Notice that 0, 0 stayed 0, 0 because whenever you multiply any number by 0, it remains 0. So it turns out with vertical compressions, this would be a compression because this number was smaller than 1, because it's multiplication on the output, and because any point on the x-axis has an output of 0, multiplying 0 by anything gives you back 0. So x-intercepts don't change with vertical compressions or even stretches for that matter. Plotting the other points, 6, 6 became the point 6, 3, and you need not even look down here to get that new point if you know we're leaving the x coordinate alone, meaning my new point is either going to be directly above or directly below my original point. Since we're in the business of cutting the y coordinate in half, this y coordinate will no longer be as high as 6, it'll only be as high as 3. So you can think of it as my new point is half as far above the x-axis than the original point. The original point, having a y value 6, means that its distance from the x-axis is 6 units, but we're cutting that in half, so the new height above the x-axis will only be 3 units. Same thing over here. Leaving the x-coordinate alone means my new point will be either directly above or directly below the original, and since we're cutting the y-coordinate in half, it'll be half as high above the x-axis as the original point, which had a height of 6. Since the y value of the point on f is 6, it is 6 units above the x-axis. We're cutting that 6 in half and making it only 3 units above the x-axis. So its height above the x-axis is only half as high. If I was to connect the dots in a very crude manner, you may see why we call this a vertical compression. We're actually changing the shape of the graph in a way that you could think of this as someone compressing or pushing down on the black graph, which was f, and putting that pressure downwards compresses it down into the blue graph. So the graph of f, drawn in black here, gets compressed into the blue graph so that its y coordinates are only half as big as the y coordinates on f. So back to the original problem, make sure that this icon is active by clicking on it. Notice that one of the points has to be the lowest point on the graph, indicated by this red dot here. So I will click my mouse at the point 0, 0, holding the mouse button down. You need not worry about accuracy right away. If you accidentally let go of the mouse, you can move that second point afterwards. So remember, one of my second points was 6, 3. Now for the equation, we were told that g of x is equal to 1/2 f of x. So g of x is equal to, and I'm just copying things down, 1/2 f of x. But remember, f of x was defined to be the absolute value of x. Since f of x is nothing more than the absolute value of x, I substitute the notation f of x with the absolute value of x. And on the computer, you can get the absolute value of x by writing abs parentheses x for the absolute values function. So clicking the answer box below, I simply type in g of x equals 1/2, or I could use the decimal 0.5, and then for the absolute value, I type abs parentheses x, click preview to make sure the syntax you typed in is not only okay, but looks exactly like the formula that I wanted. Submit your answer and verify that you get a green check mark indicating that the graph is correct, as well as the formula.